part 2. In part 2, we are going to take the synthesis and we can simulate the particular code. So synthesis process 1. So once check syntax is completed successfully, then we can go with the second option, that is the synthesis part. So synthesis part, after the synthesis only we can view the RTL schematic view and technology schematic one. So example here I can already typed the program, that's Undergate program. In this Undergate program we check the syntax is successfully, we checked one, there is no error. So here also that's a green tick mark. Now we can start the synthesis process 1. So select the synthesis 1, then run option, it runs that one. Synthesis is a process here running that one. So in a console window we can have the information about what is the current status of the synthesis one. So here we can see that one, what is your file name, what is your project name. So everything it processed, then it reading the design, then HDL compilation, then after that the HDL analysis, it takes that one. So advanced HDL synthesis process is going to done. Now we can check this one. So synthesis XST compilation over, hierarchy analysis. So once the synthesis completed successfully, then again it shows the green tick mark one. So the once the synthesis completed one, so what is the entity name and what is the architecture one, everything it shows here. Then this is your file name, experiment1.vhd, then this is a design summary one. So this design summary, it shows the synthesis results, the device utilization one. So here it's a simple logic gate only, that's AND gate only. So the available that is a number of slices and LUTs, we can see this one. So that is a number of slices used in our design, that's only one. The number of 4 input LUTs also one. Number of bounded, that's a bounded IOBs 3. So because in your entity design we have the 2 input A and B and 1 output Y, so that's IOBs are 3. These are the available resources in our design. So what device we selected, based on that one, this available source will be changed one. For example, here we selected the Xilinx, it is a Spartan 3E. We select the 100E device one. So in for that one, this is available slice. Please note down here, that's a 961. Now I change the device. Already I said in a first part. So between or after the synthesis process, again if we want to change the device, we can change the device or we can change the project settings. So for that one, we can go here, the project option, the design properties. So we can go with the design properties. Now there's a design properties window will be open. Here you see this is a Spartan 3E 100E. Now I select the another one, that is a vertex 6 low power one, for example. So here I select the lowest level, that is a 75T, like that one. So remaining things, everything is the same. I take this one and OK. So now the device is selected, this vertex one. Now again I rerun my process. This is synthesis process. The again it start with the initial step, then it generate the synthesis report file, it analyze the HDL code and generate the appropriate RTL schematic and appropriate technology schematic model one. Then it analyze that, so how many LUTs are used, how many slices are used, how many IOBs are used in our design. So once the synthesis is completed, it shows the results in the design summary one. It's a design summary. So please be wait, we will check what is the updated design summary of the device utilization summary of the device. Here that is a update. I can go with the refresh option. So number of slices value, this is a 960. Here you see this one as a target device is changed as the vertex devices one. So this is the one. So Suppose if you want to uh, dump in our uh, device or in APGA board, then next step we can go with the implementation steps. In implementation steps, it takes the translate, map, place and route model, then it add additional information. Here you see this a slice for input LUTs and bounded IO based one. So then apart from that, it shows the number of basic gates and what is the timing analysis. Here you see this one, here is only the synthesis message one, the report also only the synthesis report. So after the implementation step, you see here that's a translate is completed successfully. Then map, report, then place and route. Because it's a very simple program, it's a only logic gate one. There is no uh, impact of that translate, map or place and route. But in a complex or big projects, there are so many things we can consider here. So that is the important one. So now it's going. So after that, mapping of the target devices and the target port, LUTs, everything, it's update the timing models. So delay time, everything that will be analyzed. So after that, this everything will be enabled one. So this is a detailed report. So now it's mapping process is running. So once the mapping process is completed, we it will goes to the place on. So here the in-depth, what are the things it analyze that one. So what are the steps, manually place, and if we can give the constraint or any values, then based on that one it works. So that's a placement process is going on. Local optimization, placement of global placement optimization process, placement validations. So after successful that one, now it's uh, moving on to the place and route model. So design summary, it shows the number of errors 0, number of warnings 0, design utilization. Now we will see that uh, logic utilization part. It's updated. Wait, see, this will be changed one. So number of 6 output, output 5, number using the OJ5, ROM used in our design, memory used in our design. Okay, so logic distributions, number of occupied slices, so number with unused LUTs. Like that's, there are so many uh, in-depth analysis will be shown here. Then everything will be updated. So different types of the RAM B1, so that is a 156 312. These things can be used for the higher end projects and complex project modules. So at the time we will check the all the details. So device utilization summary, it um, click here, you can see the full window. So all the parts which are used in our design, so no partitions were found in the design because only the simple logic gates one, that is the one. So I minimize this one, sorry. Yes, now it comes, still it's running one. So now the placement, design summary, I will go check the design summary updated results. Click this one and update. So automatically it updated. Click this plus button and minus button, it automatically updated. You see this one, the previous case, that is the 961. Here that's available, things 93,121. So it depends upon the devices, the values will be changed one. So after the implementation process, what are the functional module and parts are available in our device? So what are the utilization? So everything it shows here. So that's, it is a detailed report of the after implementation one. So that's a synthesis report. So we can go with the property secondary report. Yes, synthesis all messages detailed report analysis, it comes here. So this is a detailed report. So what is the project name? So everything we can, so here you see this a DSB block, everything it shows here. So that is a detailed results. So delay also, input output delay, everything we can calculate. So what is the total delay of this one? Level of 3 logics. So that is your delay is a 0.935 nanoseconds. So that's the results. So this is the implementation process.